So the weight of this car. See, again I am telling you the key points in this chapter. The first, we started this chapter with center of mass. What is the center of mass? Till now, up to chapter number 6, we have studied point object. All the formulas that were there in our book up to chapter 6, they were applied on point object. All the formulas like equations of motion, F is equals to ma, P is equals to mv, and work done is equals to F dot S. So all these formulas, they were based, K is equals to half mv square. All these formulas we were studying. Whose acceleration we were studying? We were studying acceleration of the point object. We know that this is the point and this is the acceleration. Whose velocity? The velocity of the point object. This was the mass of the point object. Whose displacement? Displacement of the point object. Whose velocity? So all these were of a point object. But in chapter 7 we introduced extended object. So in extended object we also call it a rigid body. So we started studying in actual life. We have the rigid bodies, okay, in actual life. So rigid bodies consist of many points, right? It has these many point objects. So whose motion we are going to study, because that is okay. So now whose motion we are going to study? We are going to study the motion of center of mass. So there is one point on this extended body. This point is center of mass, and we can calculate this center of mass. We have the formulas. Now what is the role of this center mass? This center of mass behaves like we have reached back to the point object, so that all these formulas we can apply here for the point object. So we assume that the whole mass of the body is concentrated at this point. That is your center of mass. And now we will be studying. Now we have reached this same concept. So all the formulas that we have up to chapter 6 we can apply on this center of mass, on this the particle which is located at the center of mass and whose mass is the mass of the body. So the only difference is that all these formulas which are in small letters, all they will turn into capital letters. So like this first formula, F is equals to m into A. So and then P is equals to m into V, and then K is equals to half mv square. You can also write it like K is equals to half m center of mass velocity. So like this. So that is the advantage of center of mass. And center of mass, we know its formula like x coordinate. We want to find m1. So suppose it's a two particle system, m1 and m2. We did exercise question 6.2 based on that. So m1x1 plus m2x2 upon m1 plus m2. And similarly for these extended objects, we can also find with the help of integration. We can just add it m1 and x1 for all the particles and we get the formula. So like for x coordinate, if this extended body, we can write the x coordinate as adding all these masses like this, m1 x1 m1 x1. So that is x d m, and divided it like here the total mass, dividing it with total mass. So it's as simple as that. For the continuous body we always used to need the integration, and for the discrete particles we can use this formula. Okay, so that is the advantage of center of mass. Now further we studied the concept of center of gravity. So what's this concept? See, there can be two motions of this. Suppose this is a notebook that, and in class students used to try to hold this. This is this notebook. This notebook. This is sort of brick. It looks like brick. So I want to make it a notebook. So this will be the notebook, and I want to hold this notebook on a finger, right? So where do I need to put my finger? So I keep on trying here, 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 and then I find a point that here I can balance this book on my finger. So that point where you can balance this book on your finger, that point is center of gravity G. So this point was center of mass based on this formula, and here this is center of gravity G. So this center of gravity is a point where you can assume that the whole weight of the body is applied, and you are applying the force equal to that weight. So here the weight of the body, whole weight, you can assume that the body is over here, and you are applying the force against it. So that's the normal reaction. This your finger and holding this book. So center of gravity is the point where, now see, there is gravitational force acting on this particle, suppose over here. There is gravitational force acting on this particle over here. So this particle will try to, this force on this particle will try to bring this notebook down. It will tilt, and then it will little bit rotation 90 degree, and it will fall down vertically. Here also this will also try to bring it down. So this center of gravity, the particles on this side, they want to bring it down in the anti-clockwise way, and the particles over here, the gravitational force acting on it, that force will try to bring them down in the clockwise way. So but if you are holding this, it means all the torques. So now the notation for the rotational motion we need. So rotational motion, I have just discussed that there can be rotational motion here. So rotational motion, what will be these formulas? So like we have the force responsible for the rotational motion is torque, and the formula of torque is, that is R cross F, that's a cross product. So we have three cross product. V is equals to omega cross R, and P is equals to R cross, the angular momentum R cross P. So we have these three formulas. Other than their rotational part, we have these new formulas. Okay, so these are the only three new formulas that we have introduced along with the center of mass formula. And what are these formulas? Like force is equals to, so mass, next new term. So basically three new terms: center of mass, center of gravity, and moment of inertia. Moment of inertia is the same role as mass is playing. It doesn't allow the body to change its states. If the body is at rest, inertia wants to be in rest. If the body is in motion, inertia wants the body to be in linear motion. In rotational, this is moment of inertia. This torque is moment of force. This moment is this angular momentum is moment of momentum. So this is moment of inertia I, which is equivalent to m. So what does this I, the role of I? The I doesn't want the body to change its rotational state. If the body is not rotating, then it doesn't want the body to rotate. If the body is rotating, it wants the body to keep on rotating. So that's inertia, moment of inertia for rotational motion, and only inertia word we use for. So this moment of inertia into acceleration is with alpha. Now P, angular momentum, L, and that is so instead of m I have I, and instead of v we have angular velocity. So we have two formulas. One is by this is by definition of torque, this is also by definition, and another one is from their linear motion, so analog of that formula in rotational motion. And So instead of S, we have dW is equals to, so instead of force I have tau, and instead of this displacement I have this d theta. So displacement in terms of theta. So I have this formula over here, that is V is equals to omega r, and I got this formula, omega is equals to V by r. So this is another new formula. And one more, this we have studied in chapter 3 also. And what about this this omega? We can write it in terms of theta also. So omega is equals to theta upon t, or delta theta upon delta t. So that is also the formula of omega. And other than that, we have the formula. How shall we calculate this angular displacement? This angular displacement. So how shall we calculate this angular displacement? So this angular velocity. So this angular displacement can be it can be calculated like this is my a particle is rotating. So this angular displacement is in terms of theta. And what is this theta? This theta is the length of the arc, and this is the radius. So this is L by r. So theta also has two formula. Theta is equals to omega t, and theta is equals to L by r. So these are all the formulas almost that we have just discussed. So, but the important point that we are going to discuss here is center of gravity. And you know that this book is balanced. So when there is equilibrium, it means we have two kind of equilibrium. One is translational equilibrium, and another is rotational equilibrium. So translation means this body is not moving in this direction, this is not moving in this direction, this is not moving in any particular direction. Over here or anywhere means all the particles like reaching here. So that's if this book is reaching over here, so that motion is translational motion. What is rotational motion? If I rotate this, I told you that this body, like I have rotated it, and this body like it comes in vertical form, it is falling down. So it has rotated first, it has rotation, this rotation of 90 degree first, and then it comes in vertical position. So that's the rotational motion. But here when it is moving only horizontally, so here also it is horizontal, here also it is horizontal. There can be possibility that when it is rotating it becomes vertical, and then again it rotates 90 degree, it again becomes horizontal. So but that's rotation. But here if it is moving only in horizontal direction anywhere, so that motion is translational motion. But you can see the body is not rotating and not moving anywhere. So that it means there is a translational equilibrium and there is rotational equilibrium. So when there is translational equilibrium and rotational equilibrium, then all the force acting on it is zero, and all the moment of forces means all the net torque acting on it is zero. Okay. So here this car is the means same. It is an equilibrium. So this car weighs 1800 grams. So you know that this is the weight of the body, this is the center of gravity of the body, and the whole weight applies over here, and that weight is equals to mg, and that is equals to 1800 into 9.8, and the weight of the body will be, so multiply it. How much do we get? So, yes students, how much do we get? Multiplying it with 9.8, 17640 Newton. So that's the weight which is, acting at whole weight at center of gravity. Now this is your ground, and this whole weight. Now these tires are touching the surface at these 2 points, so there will be normal reaction at these 2 points. So one will be, we can write normal reaction. So if this is the front side, suppose, so normal reaction from the front tires, both the tires, and that's the back, so normal reaction, total reaction force exerted by the ground on the back wheels. So this is the normal force acting on the tires by the ground. So these are the 3 forces which are there in this figure, and further it is given that the distance between the front and back axle is 1.8. So this distance from here to here, so that this distance is 1.8 meters. Now what about this distance? This is also given to us. That is, center of gravity is behind the front axle. So it's behind the front axle by how much? So it's 1.05 meters behind. So it's 1.05 meter. So students, you know all the variables almost. And if this is 1.05, this is 1.8, how much will this be? This is 0.75 meters. So now let us draw this sort of free body diagram. You have like one force acting over here, that is NF. Here you have one force, that is NB. Here you have the weight of the body acting downwards, and here you have this distance 1.05, and here you have this distance 0.75, and this weight is 17640 Newton. So we have 3 forces, students. So when we have 3 forces, so it is in equilibrium, this car not moving anywhere, and we have to determine the force exerted by the ground level on each front wheel and each back wheel. So that is so it is by both the tires. So we divide it by 2, we get the, and here also divided by 2, we get the force by each back tire. Okay, so in equilibrium, translation equilibrium, what is the condition for translation equilibrium? So net forces in the x direction will be equals to 0, and net forces in the y direction will also be 0. So we have no force here in the x direction, all the forces. And students, this is the diagram that you need to make all the time. So this is positive, this direction is positive, and this direction, this rotational direction, this moment of we are taking this anti-clockwise as a positive. So now there is no force in x direction, only the forces are in y direction. So what are the forces in y direction? Upward forces we are taking as positive, so NF positive plus NB positive, and this force is means downward direction, we are taking it as net is 0. I told you can also write it like upward force is equals to downward force. That's also the same thing. So here that's equals to this weight, that is equals to 17640. So that's your first equation, equation number 1. Now rotational equilibrium, what is the condition for rotational equilibrium? Net torque is equals to 0. So net torque, so torque, the formula we know this, that's the formula for the torque. By definition, torque is equals to R cross F, and this tau is equals to means RF, the magnitude is RF sine theta, and R sine theta is nothing but the R perpendicular. So what is this perpendicular distance? Again I am telling you, this R perpendicular, the distance you are taking it from the axis of rotation to the point where force is applied. So that is the means this distance is your r. So axis of rotation to the point where force is applied. So suppose the force is applied upwards, then we have got the line of action. So that's the line of action. Draw it, this line of action, and then draw the perpendicular from the axis on the line of action. Okay, so that will be your r perpendicular. So here in this case, r and r perpendicular are actually same, but they can be different, like the force acting in this direction. So r is this is your axis of rotation, this is point where force is applied. So that's your r. Okay, and that's your theta, direction of r. And now what is r perpendicular? This is your extend it, and this is your theta, and this perpendicular, this is your r sine theta, and this distance is your r perpendicular. So but here r and r perpendicular are same. So students, now all the forces so you have three forces, 1, 2 and 3. So all the forces you have to calculate the torque. So first of all you need to write moment about which point. You have 3 points, you have 3 options, 1, 2, 3. You can take the moment about here also, but for you need to moment means your axis is over there. So where you are assuming your axis? So if I assume my axis over here, at any of these 3 points, at least one of the torque will be 0. Why? Because r will be 0. So let me assume it over here. So moment about O, moment about this O is that's actually center of gravity, so we can write it as G also. So moment about G. So this is what you need to write. Okay, so moments about G. So moments about G now. So let us one by one, this NF. So if here I have the axis of rotation and I am applying any force over here, so these forces will rotate it upward, of course, and if there is if any force is downward over here, then it will rotate it downward. Means this is the direction of rotation. So these directions are positive, means this direction, these directions are positive. So this direction is positive, and opposed to that, this direction is negative. Now let us see here. This is your axis of rotation. So how will it rotate? So obviously this force, any force between here G and this point, so they will rotate it in this direction. And any force between G and NB, well, of course they will bring it down, so this direction. Okay, so this direction is, of course, this is positive, and this direction is negative. So students, these are all the possible moments for all the possible forces. Okay, so now we have only 3 forces. So I have shown you how to draw the moments. So this NF, the moment will be in this direction, and this direction is negative. So minus, so tau is the formula, r perpendicular into F. So r perpendicular, how much is distance? The distance from this is the line of action, center of gravity. So that distance 0.5. So 1.05. So 1.05 into NF, and that's negative. And then now let us come to this force W. So for W, the R is 0 because axis of rotation and line of forces, they are there at the same point. So 0 into W. Now let us come to this. So this is third force. So this is the axis of rotation, and this NB will move it upward like that. So that direction is, we have taken it over here, that's positive, and opposed to it is negative. So that's anti-clockwise direction, and that's clockwise. So this is positive. So positive are perpendicular, distance between the line of action and the point so this is the line of action here, and this is the you are assuming the moments about g, so axis of rotation to line of action, that's our perpendicular. So that's 0.75 into NB, and the net will be 0. So students, like here you can see that all the negatives, if you take on that side, will become positive. So you can also write like you can skip one step and you can directly write that the moments in clockwise direction is equals to moment in anti-clockwise direction. Like here, upward forces is equals to net downward forces, like in case of Fy, and in case of Fx, net forces on the left hand side is equal to net force on the right hand side. And here moments in the clockwise direction is equals to moment in the anti-clockwise direction. So you have both the choices. So now you have two equations and two variables, students, so you can comfortably solve these equations. And now you have to force on front wheel. So force on front wheel, so we have two wheels on the front, so you will find NF and NF divided by 2. So that's your force on that wheel, so force on the front wheel. And similarly you can find the force on the back wheel also. So this is the net force acting on the wheel by the ground. So on each of the back tire, the force applied on it by the ground will be NB by 2. Okay, so I hope you will be able to solve it, yes or no? Simply finding the value of NB from here and putting it over here. There are many other ways to solve it out, students. So once you will be familiar with the concept, you will find n number of ways, shortcuts, etc. Okay, now shall we move on to the next question?
Yes, sir.
Okay, so another important concept, students. This way today only I will be revising these concepts. From tomorrow we will be at much faster pace, so telling you the concepts again and again. So next is the moment of inertia. So just like we have discussed that here in these formulas, so we were instead of m we have I. Okay, so what's this moment of inertia? How to calculate this moment of inertia? I have told you how to calculate the center of mass of the body, but how to calculate the moment of inertia? We have table 7.1 in our book, so you can see that table. So now table is on page 165. So NCERT, so to understand the concepts we have to open our NCERT book and table 7.1. So you can see in this table that we have moment of inertia. First is for the ring, when this is the axis of rotation, this moment of inertia is mr square. Okay, so that's what I equals to. And when you change its axis of rotation, like here it was from the center and perpendicular to the plane of the, but here it is along the plane, and that's its diameter. So along one of its diameter, what will be the, so here you can see here it depends on the how far away is your mass. This is this distance. So how far is it away from the, so all the mass is at distance r from the axis, but here when you are passing it through diameter, see these masses have come near to the axis of rotation. These masses have come near to the axis of rotation, and that is why this formula, this will be divided by 2. How to derive it? That is given in we'll definitely going to take the help of SL Arora also. So this is NCERT. Page number 165, 166, 167. We are going to take help of these pages, and SL Arora also we are going to take the help of the pages. Which page we are going to take the help? I told you that we are going to take the help of the pages today. 7.28 to 7.32. So 7.28 to 7.32. As we have these pages related with this concept. So students, what I was discussing is that definitely it depends, the moment of inertia depends on the mass, but along with mass it also depends on the distance or distribution of mass along, around the axis. So you can see that here the moment of inertia was mr square, and here it is this. So even if the ring is same, but still it has changed. Now if we our question is related with the A part related with the sphere and B part related with the disk. So if I write it related with the disk, you can see the formula number 4. So that is for the disk. So for the disk, you can see that this is the like the same case over here. So if this is the disk and the axis of rotation is perpendicular to the disk, perpendicular to the plane of the disk and passing through the center. So now you can see that these mass particles are near to the axis of rotation. So mass is more near to the axis of rotation. So this formula here for the disk will be mr square by 2. It means it is easy to rotate because and it's easy to stop if it is rotating as compared to the ring. So ring, you need to rotate the ring, it is twice the more efforts you need to put to rotate the ring as compared to the disk. So that's because its moment of inertia is less and its moment of inertia is more. Now if I want to rotate this disk along one of the axes in its plane, so then it will again be half. So mr square by 4. So I'm not deriving these relations, students. I'm just telling you how to remember the formula. I have derived these formulas separately, okay? I'm not deriving these formulas. I have derived these formulas separately, but I'm telling you just how to remember these formulas. Okay. And now for the sphere. So for sphere means this axis is through the center, passing through the center, one of its diameter, and the moment of inertia for the sphere is 2 by 5 mr square. Okay, so these are the formulas of and for hollow cylinder also, and for thin rod also we have the formulas. So for the thin rod it's ml square by 12. Okay, now let us start this question. So the question that we have is that we have to find the moment of inertia of a sphere about the tangent to the sphere. So this is our sphere and this is the center. So we have the center of sphere, and so for sphere we have page number 7.32 in SL Arora. So see page 7.32 SL Arora. So we have the formula. So here that's given in table 7.1. So same formula is given to us, that the moment of inertia passing through the axis. So that formula, so I passing through the diameter is given to us, and that ID is equals to 2 by 5 mr square. So how to derive it? So that derivation of this formula is given on page number 7.32 in SL Aurora. So you have seen that that's not the part of our syllabus. If you are preparing for IIT, then only you can think about deriving this formula. Otherwise for NEET also, there is very rare. Earlier when there was exam for the AIMS, that you need the derivation, but now there is common exam NEET. So the derivations are not that required for NEET students. But those who want to prepare for IIT, yes, they need the derivations. Okay. So, but for CBSE, we need not to derive the formula. So CBSE NEET derivation is not required. Okay. Now, what you need now? So you have to find the if this is your axis of rotation, this passing, the question, moment of inertia of sphere about tangent to the sphere. So IT, this is the moment of inertia about tangent. So now the sphere will be rotating like this. So here it was rotating around this axis, and now it will be rotating around this axis, this sphere. So what will be the, radius is given to you, that is r, and mass is given to you of the sphere is m. So that's along the diameter. This formula is given to us. Now how to find this formula? So students, for this, so you can see that these are the parallel axes. So we have theorem of parallel axes. If the axes are parallel, then how shall we calculate? And that is there in the in your NCERT book, theorem of parallel axes, and that's topic 7.10.1 in your book. And the formula we have over here is the theorem of parallel axes. Let us assume it as IZ and this as IZ dash. Okay, so IZ dash is equals to IZ plus mass into the distance between these two axes. Okay, so distance between these two axes in your book, it is written as A. So that's A. So that's equation 7.37 in your NCERT. So its derivation is not required. If you want to derive, the derivation is there in the SL Aurora book. Okay, so we can comfortably find, so this IZ dash, so students always write the standard form, these standard formulas in the NCERT, always write them in this form, and then you can change whatever you want to do. So now here my IT is, this has become my moment of inertia about tangent. This was moment of inertia when I was considering the axis as one of the diameters. So this is and plus, now this is m, and how much the distance between these two axes? The distance between these two axes here, A is equals to r, so that's mr square. So now this I tangent, I diameter is given to you, 2 by 5 mr square plus mr square. So 1 plus 2 by 5. So this is the same thing that they have given in SL also. The answer is 7 by 5 mr square. So they have derived it, and after derivation, then as a B part, they have solved it. So students, but the difference is the solutions between SL Aurora and here is we are following the NCERT. The same means the variables and everything from the NCERT. So that you will find only from my notes. Anywhere else, all the teachers, they have different ways of telling the same thing. All of them are right, but we are following the NCERT formulas, NCERT variables, so that's better for us. Okay, now next question, B part of this question. So B part, we have now the disk of mass m and radius r is given to us. So we have this disk now, and about any of the diameters now, any of the diameter, it is given to us that is so this formula is given to us, students. This is given to us. Earlier on this was given in A part. and in B part this is given to us. Okay, so along one of its diameters. So this is one of its diameter, it is given to us. So, and that is you know that this along one of the diameter, this ID, so ID is given to you, and that is mr square by 4. Okay, now we can derive it in SLR. The derivation is given, the whole the disk concept, that is on page 7.29 in SLR. Those who are interested in derivation, preparing for IIT, they need to work a little bit hard, want to be engineers. So ID is equals to mr square by 4. Now what we need to find here in this question? So we need to find the moment of inertia about the axis normal to the disk. So now read the question carefully. This is your disk. So where is your axis? So axis is normal to the disk. So axis is normal to the perpendicular to the plane of the disk, right? First thing, and passing through a point on the edge. So all these axes are perpendicular to plane, but which out of these, which ones you are going to choose? So this one, the one which is the tangent. Okay, so this one you are going to choose, not these. So axis is perpendicular to the plane of the disk, and it is also passing through a point on its edge. Okay, so passing through a point on its edge. So this is the first thing, and passing through point on edge. So this is where you need to find. So students, like along any diameter, that's the same. So this diameter can be here, and even this diameter can be here also. That's also diameter. So these diameters are in the plane. Don't get it confused, okay? In the plane of disk. These diameters are in the plane of the disk. Is this clear? So this now we have a formula. So what we will be deriving from this formula, we will be deriving first this formula. Okay, from this to this. Okay, so how we are going to do it? So we have theorem of parallel axis, and we have theorem of perpendicular axis, because this axis is perpendicular. So this axis is perpendicular to the disk. Okay, and passing through center. Okay, so and then with the help of so parallel axis, we transform from here to here. If we know this, then this distance r, so we can derive this formula ultimately. So first of all, we are deriving it for the perpendicular. So perpendicular axis, what's the formula? So that's the theorem of perpendicular axis given to us in our book. So this we can consider it as x-axis. So this is my x-axis, this is my y-axis, and this is your z-axis. Okay, so students, that's your z-axis. So the formula that you have is that if you want to find in the perpendicular, so this z-axis is perpendicular to this plane x and y. So you have two mutually perpendicular axes. First of all, this x-axis and y-axis, these are two mutually perpendicular axes, and z-axis is further perpendicular to these two. So then this theorem says that Iz is equals to, so simple students, Ix plus Iy. Okay, so this is the these two axes, the angle between them is 90 degree, and this z is further perpendicular to Ix and Iy. So it's as simple as that. Okay, Now putting the formulas here, Iz is equals to, so this is your Iz, this you are considering as z-axis, so that's your Iz you are calculating here, and then we'll be calculating Iz dash. Okay, so Iz is equals to Ix, and they are all diameters, moment of inertia along diameter, and Iz is equals to, along diameter it's mr square by 4 plus mr square by 4, and that's equals to, so half, so multiplied by 2 same, so 2 and this cancel out, so anyway you can think, so mr square by 2. So now we know along z-axis, so along z dash, so Iz dash is equals to same theorem of, so this was theorem of perpendicular axis, because this z-axis was perpendicular and this is parallel to Iz. Okay, so theorem of parallel axis, and that's equals to, that's your theorem of standard equation 7.37, and that was your this was your equation number 7.36 in your book NCERT. Okay, so what this formula, this Iz dash is equals to Iz plus ma square, and now so that's theorem of parallel axis. So when the axes are parallel, one parallel axis is given to you, how you will find the the moment of inertia about this parallel axis. So this axis is given to you, so this Iz dash is parallel, so Iz dash is equals to Iz, that is this mr square by 2 plus m, and what is this a is your r. So the distance between the axes, some of the time we write it as, in NCERT they write it as d also. Okay, so that's the same thing, so that's r square, so mr square by 2, so that's Iz dash. So first of all we derived this formula, this Iz, and then this is 3 by 2, so of course 1 plus half is 3 by 2 mr square. So students, we have done very important concepts today. So we have calculated the, how do we calculate moment of inertia, and you know how important the moment of inertia is. Why? Because all the formulas of masses in the linear motion have changed into rotational motion. So this mass here, you need not to calculate this mass. This mass was no formula for this mass. Okay, but here in all these three formulas you need the moment of inertia. K is equals to half I omega square. So you need I. How to calculate this I? So that depends on the object, its mass, and then further its axis of rotation. So students, this is what it was all about. And now the you have next question. That's pretty simple based on this concept. So that's, that is my question 7.11. So here we have the torque of equal magnitude are applied to the hollow. So here we have hollow cylinder. So we have hollow cylinder, which is there in the table 7.1. So you can see that this is hollow cylinder. That's the formula number 6. So in case of hollow cylinder, so this hollow cylinder is given in your book. So this along this means you have given the moment of inertia is equals to mr square. Okay, both having the same mass and radius, so it's mass. So another is solid sphere. So solid sphere we have just done, we have just completed. So you can write it means passing through the center, over here, anywhere, that's the same thing. Okay, so here the moment of inertia will be, so you can write it as, so in case so for you can take as I1 I2, that's your choice, I1 I2 I dash, or you can also take it like this is your cylinder and this is your sphere. So you can take it as IC and IS also. Okay, that's also your choice. So that's for the sphere we have just done it, that is 2 by 5 mr square. Now the cylinder is free to rotate about its center axis of symmetry. Okay, so this will be the rotation, and the sphere is also free to rotate through the axis passing through its center. Now, which of the two will acquire greater angular speed after a given time? So what is the difference? So angular velocity, and when we are talking about only the speed, so only the magnitude of the angular velocity. So this is velocity when I have speed plus direction. So I have only speed, so angular speed, so that's omega. So we have to find omega. Okay, so now what are the formulas for so this is same as velocity. Okay, so what are the formula for this moment of inertia is equivalent to mass, and this this is equivalent to v. So what are the formulas that are connecting mass and velocity? So whose angular velocity is more? So we are not find the actual speed, so but we have to find whose speed is better. So obviously, first of all, when we apply the rotational force, there will be when we apply the torque, so due to the torque there will be, like in the force, due to force there is acceleration, and then there is change in velocity, and similarly here torque and then angular acceleration and then angular velocity, right? That is the way out. So now what's the formula which is to find the acceleration first? So F is equals to ma. So in rotational motion we have the tau is equals to instead of mass I have I, and this is alpha. So tau is equals to I alpha. So that's the formula that we have. So I will find this alpha for both the cases, and then more is the alpha, more will be the angular velocity. Okay, so in the first case this tau for the cylinder is equals to I for the cylinder and alpha for the cylinder, and for the sphere, tau for the sphere is equals to I for the sphere and then alpha for the sphere. So we have to find the alpha. So alpha for the cylinder is equals to tau upon cylinder divided by IC, and here alpha for the sphere will be equals to, means angular acceleration will be equals to the torque acting on it divided by that. So students, equal torques are applied. So these torques are equal. So if now you can compare these two. So if these are same, so this is constant. So when the torque is constant in your formula, alpha is equals to tau upon I. So this is constant. So when this is constant, so it means alpha is directly proportional. Here it is inversely proportional. So inversely proportional to I, right? So greater is the I, lesser is the. So of course, greater is the I, you will have a lesser angular acceleration. So whose moment of inertia is greater? So moment of inertia, of course, this is 0.6 mr square. So this is 1 mr square. So IC is greater than. So clearly it is for cylinder it is greater, because see the distribution of mass is away from the axis of rotation by the distance r, and here the masses are near to it, near to the axis of rotation. That is why it is 0.6 and it is 1 mr square, right? Because the masses are away from it. So that is why it is difficult to rotate this cylinder as compared to sphere. So this IC is greater, so of course alpha for the cylinder will be lesser because it's inversely proportional, you can see. So this alpha will be lesser for the greater inertia, and so angular acceleration of the cylinder will be lesser. So for the sphere it is more, so and velocity is directly proportional to the alpha, right? So velocity is directly proportional to the alpha. So more is the angular acceleration, more will be the velocity. So here angular acceleration of C is greater, therefore the angular acceleration of sphere is greater, so velocity of sphere will be greater than velocity of the cylinder. So this was the question based on this. So velocity of here the sphere will acquire greater angular speed after a given time. Now let us do one more question quickly, not just 2-3 minutes it will take, because that is also based on the same concept, even the next two questions. So 7.12. So we have a solid cylinder whose mass is 20 kg and rotating about its angular speed with this. So this is, students, very simple question. Okay, so m is equals to 20 kilogram and omega is equals to 100. So directly given in SI units. Okay, need not to do anything. That's your angular, and the radius is given to you. The radius. So you have again cylinder here. So that's your axis of rotation. So now the R is given to you, that is 0 point. So all the units are in SI units already. And what is the kinetic energy associated with it? So you know the formula. What is the first of all moment of inertia? For this, that you know, that is equals to moment of inertia of the cylinder about its axis. So about its axis, it's mr square. Okay. So what is the kinetic energy associated with this? So that's the moment of inertia. We have just did it in this question also. So that's moment of inertia. See the students, see the difference. Here it was hollow cylinder. Okay, so hollow cylinder, so the particles were away, and here we are talking about, so don't get confused, it's solid cylinder. So in solid cylinder the particles are more near, so the moment of inertia will be like in case of disc and ring. So here also it will be reduced by half. Okay, same way. So same way to remember the formula. So now you have this R. So kinetic energy, you know, kinetic energy is equals to half mv square. So here kinetic energy is equals to half I omega square. That's rotational kinetic energy. We can write it with k dash. So simply finding the value from here, that's half into 20 into 0.25 square, and that comes out to be 0.625 kilogram meter square. So put this value of inertia, and you know the omega. So k dash is equals to half into 0.625 into omega square. Omega square is 100, so that's 100 square, and you will find it 3.25 joules. So that's the first part. Now second part of this question, what is the magnitude of angular momentum? So angular momentum, okay, so momentum formula we have P is equals to mv. So here angular momentum, you can write L, and I will be replaced with m this way. Okay, so always write the linear formula and then write the rotational part. So L is equals to I omega, and L is equals to I is your 0.625 and omega is your 100, that is given this. So this comes out to be 62.5, and you need to write unit, students, otherwise marks will be subtracted. So that's the question 7.12. So we'll do the remaining questions from tomorrow, same time, be on time in the morning, and thank you for being with me. Thank you, students.
Thank you, sir.
Thank you, sir.